Hello, welcome back to all. So now we will start the next session after the break. So the next session will start with Dr. Roland Webber's talk on Introduction to PBDE, HBB and HBCD and basic information on developing related inventories. Now I am giving the floor to Roland. So Roland, please go ahead.
Yes, thanks, Yasser. You can see my screen, you can hear me?
Yeah, perfect. Go ahead.
Okay, good. So this presentation is about the introduction to the listed brominated POPs and to develop related inventories. You see here the structure of the listed POPs, the brominated diphenyl ethers, the brominated biphenyl in the middle, and wait a moment, I can also laser pointer, and the hexabromocyclododecan, the commercial penta-BDE and commercial octa-BDE has been listed in 2009 together with hexabromobiphenyl, all in Annex A, and here in 2013, the hexabromocyclododecan has been listed, and then more recently, 2017, also the decabromodiphenyl ether has been listed. So these are the 5 different commercial products. And the one which I will not address is here the hexabromobiphenyl, because it has only been produced in the 1970s at a quite low amount, 5,000 tons around. So therefore it is not relevant anymore. So this presentation will be on the others, which also have a relevance in use and in stock and in exposure. So first, the most important ones are the polybrominated diphenyl ethers. These are a group of industrial chemicals which have been widely used as additive flame retardants since the 1970s in plastic, polymers, and synthetic fibers. They have been produced in 3 different degrees of bromination. So the pentabromodiphenyl ether has an average bromine content of 5 bromine, but it also contains tetra, penta, and hexa and hepta. Then the commercial octabromodiphenyl ether has an average bromine content of 8, but it also contains hexa, hepta, octa, and nona. And the major commercial product was and is the decabromodiphenyl ether. This is the fully brominated diphenyl ether. So always good to know the total production volumes of chemicals and when they have been produced. In total, we have production of PBDEs between 1.3 and 1.5 million tons in history. So that's similar to the amount of PCBs. The commercial penta-BDE and the commercial octa-BDE has been produced both around 100,000 tons, while the commercial deca-BDE has been produced by more than 1.1 million tons. The production of commercial penta-BDE and commercial octa-BDE have been stopped in 2004, and only the production of decabromodiphenyl ether continues. They have a range of adverse effects to humans. They are strong endocrine disrupting chemicals. This means a hormone-like substance. By this, they have effects on the reproduction of males and females, on diabetes, and a very important adverse effect is on the development of nervous system in children. Here, especially the commercial penta-BDE was or is associated with substantial neurodevelopmental deficits. Children with higher PBDE levels showed 5 to 8 points lower IQ score, which is quite much and quite relevant. We have seen that while for DDT, for example, in human, so that's human milk in Sweden, measured for POPs from 1970s to 2000. And you see, while DDT and PCBs have decreased over time, the green one, these are the PBDEs, they are increasing since the production has started in the 1970s. And Sweden already took action in the 1990s to reduce the use and prohibit the use. And so in this country, you see already in the 1990s a decrease at the end. This is the data of the human milk study from WHO and UNEP from in total more than 80 countries. What you see is that here the human milk of the United States is for the PBDEs the by far most contaminated ones. And even some countries neighboring the United States are impacted, like here Haiti, Antigua, Mexico, with higher level of the PBDEs. The reason is that most of the PBDEs we find in humans come from the commercial penta-BDE. So they are most bioaccumulative, and also they have the most facilitated exposure because they can migrate and have some volatility. And 90% of the commercial penta-BDE has been used in United States and North America. So therefore the level in the human milk is that high. Also, there is a calculation of external costs in the United States from PBDE in humans, and it is estimated that the total cost per year is $266 billion, especially caused by these developmental effects in children. The good news is that the PBDE levels in Europe, Africa, Asia, and certainly also the Middle East is about 50 times lower. Yeah, so most countries which are not affected by the penta-BDE use in the US has much lower PBDE content in blood and human milk. Another interesting fact in respect to assess the toxicology and toxicity of the PBDEs is that the PBDEs, especially the Decabromodiphenyl, is a very good precursor for the brominated furans. And the brominated furans are similar toxic like the chlorinated furans and dioxins. So we measured Ewaste plastic in Nigeria, and we found high levels of brominated dioxins in this plastic, and especially those which contain PBDEs. In total, it can be estimated that the 1.1 to 1.4 million tons of PBDEs have formed about 1,000 tons of brominated furans, which are still in products. And there was a recent study of children toys which have been recycled and from recycled plastic, and several of them contained high brominated dioxins at a level of a fly ash. How good the precursor potential of Decabromodiphenyl is, you see from an experiment of Professor Vetter. So he took some fish and put some Decabromodiphenyl in the fish, and fishes can be contaminated with Decabromodiphenyl. And then he was cooking the fish, and during cooking of the fish, the brominated Decabromodiphenyl decreased, and at the same time, brominated dioxins increased. So just by cooking, brominated dioxins were formed out of the PBDEs, increasing also the dioxin-like toxicity. Yeah, so they have analyzed that also with bioassay sensitive to dioxin-like toxicity. When we look into details how the PBDEs were listed, so the Conference of Parties decided at the fourth meeting in 2009 to list certain congeners and homologues. So these are the tetrabromodiphenyl ethers and pentabromodiphenyl ethers, hexabromodiphenyl ether and heptabromodiphenyl ether. So the lower brominated diphenyl ethers, and actually the commercial penta-BDE just contain these homologues, and also the octabromodiphenyl, the commercial octabromodiphenyl ether consists mainly of hexabromodiphenyl and heptabromodiphenyl. So by this listing, both commercial PBDEs were addressed by the listing. Then there was a longer discussion over some years in the POP reviewing committee about the listing of the decabromodiphenyl ether. There was a long discussion about the debromination of this higher brominated diphenyl ether, because partly it's debrominated to the lower brominated ones, and like I showed, also the dioxin formation potential. And then in 2015, also 2017, also decabromodiphenyl ether were listed. It was also listed in Annex A, but with an exemption for the production, allowed for exempted uses, and a range of exempted uses were listed in the convention. And the current status is that several countries have registered for the exemptions. The exemptions for DECA-BDE in the Stockholm Convention includes use of textile in the textile production, where they need to be non-flammable, but not allowed for clothing and toys. Then exempted is additives in plastic housing, especially for heating home appliances like irons, fans, and heaters. Also exempted is polyurethane foam for building insulation, certain parts in the use of vehicles, and also certain parts of aircrafts. And when you look to the exemption in respect to the PBDEs listed in 2009, they do not, there is no allowance of production and use, but when the PBDEs were listed in 2009 at the Conference of Parties, some parties said, oh, but what is this recycling of plastic containing these PBDEs? Do we need to stop all recycling of e-waste plastic? And then the recycling was finally exempted, yeah, for the PBDEs. When DECA-BDE was listed in 2017, no exemption for recycling were granted. So there is at the moment a discussion on the low POP content. This means at what concentration, for example, of e-waste plastic mixture, it would be considered a POP waste, because the limit here defines if e-waste plastic can be recycled or not. So this is a first very good example of a hazardous chemical in plastic, which now cause global trouble in respect to recycling. And it shows how important it is to use the right chemicals as additives in plastic, but also as additives in other products that we can move to a circular economy and improve our recycling. Also good to look to the time trend of the use. Here you see for Japan, they are big producer of cars, big producers of electronics. So Japan is using much of these brominated flame retardants, but the Japanese government and industry already decided in the early 1990s to stop the commercial penta-BDE. Yeah, and what you have seen before from the slides, yes, commercial penta-BDE has the highest risk of exposure, the highest toxicity, So very reasonable and very good that they already stopped early 1990s. Also, the commercial octa-BDE in Japan was already stopped around 1997-8. When you look to, but the commercial Deca-BDE has been strongly used in the 80s and 90s, but you see also starting from the early 90s, the Deca-BDE was reduced in the overall use of flame retardants of electronics in vehicles in Japan. So this is different in some other countries. For example, for United States, the commercial penta-BDE and the commercial octa-BDE has been used until here 2004. And also China used the commercial penta-BDE until 2003 and 2004. Here we are at the picture, include also the hexabromocyclododecan. We will come later, but just to see, yes, this increased over time also for Japan. Until then, in 2013, it was listed in the Stockholm Convention. Japan stopped here in 2013. And a good news, China, as the last producer of hexabromocyclododecan, has stopped the production of hexabromocyclododecan last month, October 2021, by a CHEF project. But other brominated flame retardants are increasingly used. Yeah, so again, here the data of Japan, where you can later on, when you have the presentation, see the more detail. But there you see that overall the brominated flame retardants have increased also 2000 up to 2010. And the main use is tetrabromobisphenol A and the derivatives, which are strong endocrine disrupting chemicals, and also other flame retardants like tribromophenols, which is an endocrine disruptor, and even hexabromobenzene. Yeah, so you know, hexachlorobenzene is a POP since the beginning of the convention, but hexabromobenzene, which is certainly also a POP and has POP properties, it is still used as brominated flame retardant. What were the major uses of the individual PBDEs? So commercial octa-BDE has been used mainly in plastic of electronics, and they are mainly in a housing of cathode ray tubes. The commercial penta-BDE has another use. Most of the commercial penta-BDE, more than 90%, were used in polyurethane foam. Yeah, and yes, 90% were used in the US, and the largest share here in the transport sector and in furniture, yeah, in the polyurethane foam. Most countries do not have flammability standards which request that the polyurethane foam itself is flame retarded, and that's the reason why here the United States has a special high use. It was the flammability standard which was driving that use. So then we have a minor use of commercial penta-BDE in textiles and rubber. And when we look to the decabromodiphenyl ether, decabromodiphenyl ether was used in all those uses, and as you have seen, in more than 10 times the amount compared to commercial octa-BDE and commercial penta-BDE. So when you look to the total amount of plastic and plastic use, you see that here some of major use like the electronics, the transport sector, and the building sector here, especially the insulation, this is impacted by this brominated but also chlorinated flame retardants. Yeah, so when you start now to look to these brominated flame retardants, at the same time you can think more broad in a sense to look to problematic additives in the major plastics you have and you need to manage. Because in these plastic, we have also other POPs like the chlorinated paraffins. We will come tomorrow to it, but we have other hazardous chemicals like phthalates and bisphenol A, which are endocrine disruptors, and even heavy metals used in some of these plastics. So while we focus in this workshop on the POPs and also in your development of the NIP, I recommend you to look broader, into pollutants when you come now to big materials and recycling flows to adequately address these material flows and the recycling in respect to pollutants. Here also the life cycle for the PBDEs, but also the other brominated flame retardants. You have here the production of those chemicals and release reservoirs to landfills, the use in electronics, in the car industry. From there, it goes into products, it goes to the consumer. During the use of these products, they are released to the environment. At the end of life, often they are just disposed to landfills and dump sites, especially in developing countries, including Palestine. And like I showed for PFAS, a major exposure for humans is the indoor exposure of these products, or the indoor exposure in certain cars which contain PBDEs. Yeah. So when you do an overall assessment of exposure, especially for countries with high use like the United States, this kind of exposure is by far the dominating pathway. While there is also accumulation in animals and cattle and in fish. And for countries like Germany, but also probably the Middle East, let's say both exposure pathways might be relevant, but as you have seen, are much lower compared to the United States. But if you have the wrong car, maybe a car from the 1970s or 80s or 90s from the US, you might still have commercial penta-BDE and be highly exposed. And then we have the recycling of these materials. And in the last 15 years, there were a range of studies of recycled plastic in respect to these flame retardants. Here you see the study of Chen, where he assessed the children toys in China. And in all the plastic children toys, he found brominated flame retardants, including PBDEs. Yeah, so you see that recycling often went into these simple products. Another example here, Miriam Diamond, professor at Toronto University, friend. So she analyzed her kitchen tools, including these salad servers. And the salad servers contain 1,000 milligram per kilogram of PBDEs and also some lead. So when you make salad, then with the oil, you extract the PBDEs, and with the vinegar, you can extract the lead from this recycled plastic. A last example here is a coffee cup. And here it is these black plastics from the coffee cup lids, which contained also up to 1,000 milligram of PBDEs per kilogram of plastic. And then with the hot coffee, you can suck here also some flame retardants. So what we saw by this, and I am so happy that the PBDEs and some of the brominated flame retardants have been listed, is that the recycling flow of the PBDE and brominated flame retardant containing plastic seemed largely uncontrolled, and that we need a better life cycle management globally and control. And therefore, it is so important that we have these compounds in the Stockholm Convention. So in Stockholm and Basel Convention, guidelines and guidances have been developed for the waste management, but also for the recycling and separation of these materials. Another example is, again, kitchen tools from a study in the UK. So here they had also kitchen tools which were contaminated with PBDEs, and then they made an experiment. They took cooking oil, and then they put the kitchen tools 15 minutes into that cooking oil, and you see already after 3 times most of the PBDEs were transferred from the kitchen tools into the cooking oil. Like before, also here, I would like to highlight the substance and material flow. This is an example from Switzerland, where you see, yes, assessment of the imports. Also, Switzerland did not have a production of brominated flame retardants themselves. So everything, the products, but also the chemicals were imported, go into the production, then in the use, and from there, then into waste incineration, to the landfill, but also to the recycling. Yeah. And so this kind of substance and material flow is so nice for policymakers, because on one slide, you can show kind of the whole story of the materials which are impacted. And even if you want, you can include here the environmental part and the release to the atmosphere, soil, and hydrosphere. But again, here, yes, like the colleague said, volatile, non-volatile. The Decabromodiphenyl is a kind of dead dog. It's really not a volatile, so we are talking and not water soluble, while the PBDE can be evaporated and also can be detected in leachates. That's a simple material flow analysis we did for Nigeria, where also there was a student in the beginning of a project. I had the first global project for developing an inventory, and they choose Nigeria as a case study. So I linked him to Vienna University, which have an open access tool for material and substance flow analysis. And by the data of Ewaste project in Nigeria, he could develop a simple material and substance flow for the PBDEs in the Ewaste plastic. How much is in use? How much has come to the end of life in that 10 years? And then to assess how much is going to landfill, open burning, and how much is going to recycling. So I think quite useful and interesting for a university. And also for the policymakers, the industrial chemicals which are still in use are really interesting, because you need to look to the imports, you need to look to the industry, you need to look to the trade and to the recycling and to the end of life, and you need to check. We have heard this morning in the first presentation on legislation that there is a lack of legislation. So yes, so you need to check what kind of legislation do you have, then what kind of competent authorities which are responsible to look to implement legislation. So here these new industrial POPs are, in my opinion, also a kind of case study where you can learn to develop such regulatory frames, and including the implementation frames. Shortly to hexabromocyclododecan before we come to some inventory considerations. Hexabromocyclododecan had been also produced in huge amounts. It was mainly used expanded in extruded polystyrene. More than 90% of the HBCD was going into this insulation foam. So when it was listed in in 2013, it got an exemption for further use in the insulation foam. But this exemption expired already. And like I said, China stopped the last production in 2010. But of course, the use of all the insulation foams, and insulation foam has a very long service life of 30 years, 50 years, up to 100 years in building. So this can be continuously used. But at the same time, countries will have the challenge to manage these insulation materials the next 50 and 100 years from construction. What were the obligations of the convention for HBCD? The production and use were allowed, and there is a continued allowed use, but there is no allowed of recycling of articles containing hexabromocyclododecan above a certain level, and the low POP limit here is set to 100 milligram per kilogram, and otherwise it needs environmentally sound management and disposal. Coming to the inventory, also for the PBDEs, we have a detailed inventory guidance, actually just updated 2021 to combine all the PBDEs in one inventory guidance. And like I showed for the PFAS guidance, we have a chapter on the background of a listing of the PBDEs in chapter 1, then the formal production and use of the PBDEs, the different inventory steps for the PBDEs, and then for the individual use, including import of PBDEs and production, because it's still allowed, and the use in production. And then the most important for Palestine is the presence of the PBDEs in products like electronics, the transport sector, but also the construction materials. Yeah, I do not consider, for sure, you do not have a production of the PBDEs, and probably you do not have an industry which is using PBDEs, but this you can assess in the inventory development. So coming first to electronics quickly. Electronics is not only relevant because of PBDEs, that's the smallest part of the problem, but yeah, as probably all of you know, e-waste is a big waste stream. It is actually the most fast-growing waste stream in the world. Today we have about more than 53 million tons of e-waste a year. And the average plastic content of e-waste is about 20%. Yeah, it depends a little bit on the type of e-waste, but the overall, the average is 20%. This means the 53.6 million tons of e-waste contain more than 10 million tons of e-waste plastic, which we need to manage every year. And it is not only PBDEs, which are pollutants in the e-waste, but also some of the e-waste contain polychlorinated biphenyls. Some of the e-waste contain chlorinated paraffins. We have chlorofluorocarbons, CFCs, and HFCs and HCFCs, which are ozone-depleting substances and greenhouse gases, especially in the air conditioners. We have a range of heavy metals in e-waste which you need to take care in the end-of-life management, including mercury, which is addressed by the Minamata Convention. So therefore, also here, please do not only focus on the PBDEs, but we need to look also to other pollutants when we are talking about end-of-life management and recycling. But at the same time, e-waste plastic is one of the most valuable plastic. It's high-quality plastic, and actually e-waste plastic, which is not contaminated by POPs or other hazardous chemicals, can be recycled. So e-waste plastic is certainly a business opportunity. Yeah, it's a high-value plastic, and every year you get more and more and more of this plastic. Yeah. So, and at the end of life, it is also costly to process. So if you find a good way for separation of the plastic, yeah, it is straightforward to recycle those plastic which is not impacted. Yeah, it is good in respect to resources. It is good in respect to climate change considerations. This means recycled plastic has a smaller CO2 footprint compared to new e-waste plastic. So yes, it is very important that we think about it, but it is also important that we do not recycle the wrong plastic. And here I'm quite happy that we have developed BAT-BEP guidance in the Stockholm Convention, which shows methodologies how to separate the plastic that finally those which contain PBDEs can be destroyed, and other plastic after separation. It is quite complex, the whole process, but can be recycled into new products. So when you think about the inventory, the first thing what you should look at is if your country already have inventory on electronic waste. because if you have inventory on electronic waste, you can use this inventory and then build out of this inventory PBDE inventory. Yeah, but if you do not have e-waste inventory in Palestine yet, then maybe you can use this activity when you start to do such an inventory of PBDEs, that you rather think to develop inventory for e-waste. Yeah, and within the inventory of e-waste, then at the same time you also assess the plastic and the PBDE in the plastic and how this plastic is managed in Palestine. It is the same approach for the inventory, planning the inventory, choosing data collection methodology, collecting the data, managing and evaluating the data, and preparing an inventory report. Again, here you look to the major stakeholder, which ministries have the responsibility for waste, but also the Ministry of Industry, which probably also in Palestine is thinking about more circular economy. So they might or should be interested on the e-waste topic and how to get the resources out of the e-waste, but then also recyclers, importers, retailers. Yeah, all this information is also then in the inventory guidance, where you have these kind of list. Yeah, and in the beginning, in Palestine, when you have a smaller capacity and smaller human resources to do this assessment, think if you just limit it to certain electronics, yeah, or first look to the households, or first look to the institutional consumers like hotels and industries, yeah. So defining the scope of the inventory. And then the inventory approach, the same, to do first a desk study, and then to see for the data collection how far you come with statistics or with questionnaires. Also, this is, I think, something really interesting for students. With my Nigerian student, for example, we have done a study on mobile phones. So he has interviewed his colleagues and have assessed the whole mobile sector in Nigeria, and has also done some screening. So also a quite interesting opportunity for students, and quite close to the normal life. Then transport sector. The transport sector is also a large material flow of goods and waste for recycling and recovery, cars, buses, trucks, trains. And in developing countries, the transport fleet is often growing. It is high relevant for the material flow and recovery of the materials, especially the metals, but also managing the pollutants. So there are different flame retardants. Here, the commercial PBDE is especially in the flexible polyurethane foam of cars. Then commercial Decabromodiphenyl is frequently in cables and in textiles of vehicles. Also, hexabromocyclododecane can be found, but at lower concentrations inside vehicles. And we have other POPs in vehicles like chlorinated paraffins or PFOA in cables and in the textiles of the seats of cars. So the data you would gather there is normally first quite easy, because you would look to the registered vehicles. And I think also Palestine will have a registration for the vehicles. And then what we will need is the different year of manufacturing and the approximate distribution of the vehicles coming from different regions. And also you can check the import and the export of vehicle to understand the flow of vehicles, and they are the plastic polymers in the vehicles and the PBDEs in those polymers. And then we have developed a relatively simple calculation method to estimate the PBDE content of your vehicle fleet. Yeah, so for vehicles which are older than 2005, the average content is about 80 gram of especially Decabromodiphenyl. For vehicles produced between 2005 2017, it is lower, about 20 gram. You have seen also for Japan how this has decreased over time. And then we consider that vehicles which are produced after 2017 don't contain PBDEs. Yeah, but you see, by this kind of impact factor approach, also Palestine, which do not have the capacity to do real measurements, can do a first halfway robust inventory of their PBDE for vehicles, and the same with the impact factor we also have for the electronics. Yeah, coming to the last major sector, this is buildings, and here the plastic and polymers in buildings, especially the insulation foam. So the major use brominated flame retardant in insulation foam is the hexabromocyclododecan, more than 90% of its use, and this was used only in polystyrene, the EPS and XPS here in the buildings. When you look to the PBDEs, their use in buildings was more diverse. So partly it has been used in insulation, in polyurethane foam, and partly in polystyrene foam. The polyurethane foam is still exempted. Then it has been used and is possibly still used in laminates of insulation panel, in the piping, in films under the roof to protect building areas, and also in cables and in ducts of fittings. And there are other POPs in construction. So here, when you think about plastic and polymers in construction, I would recommend you not only to look to the brominated flame retardants, but also look to chlorinated paraffins. We will come to it tomorrow in a presentation. And also in history, PCBs and polychlorinated naphthalines have been used, for example, in sealants and in paints in buildings. And certain pesticides have been used in wood, like pentachlorophenol, DDT, lindane, endosulfan as a wood protection. So also here I would recommend you just do one assessment of your building and construction sector to understand what kind of problematic additives you have in your building and construction material, to understand exposure, to understand what kind of regulatory frame you need, and especially to understand what kind of measures you need to do when you have a demolition of buildings. Also here for the buildings, at least you can do one calculation. This is for the hexabromocyclododecan, where normally it is not too difficult. These are normally only 1 or 2, 3 companies which in a small country like Palestine are responsible for building insulation. And in the building insulation, we know that before 2015, basically all polystyrene in building insulation was flame retarded with hexabromocyclododecan, if it was flame retarded. And we know the concentration of HBCD used, and therefore also here you can make a simple inventory first of your HBCD in the buildings. Then we come to managing and evaluating the data. At the end, when you have these data compiled, you can compare with other countries. You can involve some expert to evaluate the data. And then after comments, you can maybe refine the inventory, or the inventory is good enough for the NIP. And in the NIP, you can then decide on further action. And also for this PBDE and HBCD, Shireen will give you more details in yeah.
Okay, thank you, Roland.
Yes.
Now I am welcoming from the audience for their intervention. So please raise your hand and you can make the intervention now.
Is there an e-waste inventory, or is there any e-waste activity in Palestine? Do you know what happens with the e-waste in Palestine?
Yeah, I think Bilal has raised his hand. Please go ahead, Bilal.
Until now, no any survey. There's some study from a student in some university about e-waste, and here until now we didn't made any survey about e-waste officially.
Yeah,
especially in Environment Authority.
Yeah.
But my question related to the auxiliary, that the mobile came with cover, came with many auxiliary used in the electric waste. This is included also or not?
You mean the mobile phone issue? I mean, in the mobile phone, you do not have much plastic. Yeah. So therefore, normally for the flame retardants, you are especially interested in the big ones like televisions.
Yeah. This is what I think about it. But
computers.
We use it so much here. We like it.
Yeah, it's not the small mobiles. I just made this, let's say, this example because I mean, mobile is one of the valuable thing which you need to take care very early. Because I mean, you can sell it on the market. So I think it should not be difficult also to get money by gathering the mobile and by exporting the mobiles. Okay. And also, of course, by refurbishing the mobiles, reusing the mobiles. So therefore, I mentioned this mobile phone because it's something easy for the student, I mean, to deal with, and it's very close to their life because I mean, probably every student has one. But of course, it contains a low amount of the plastic, but it contains some flame retardants. I can send the study which we have done. Yeah.
To be honest, when you presented your presentation, I review our technical regulations related to toys. I didn't find anything mentioned about this product in it. So I don't know why, but because our directive, our technical regulation, European technical regulation, but I didn't see anything mentioned about this product in it. Maybe European directive changed it and we adopted the old edition. Maybe I don't know if this is regulated in a European direction or not. I review food and I review the toys, but I didn't find anything in it.
Yeah. I mean, you do not have it in food. Yeah. And also there is no, let's say, regulatory limit in soil, for example. Yeah. But you can find in the contaminated site section something on environmental guidelines. For PBDEs, there is in Europe, there is environmental quality standard in respect to fish and rivers. You have in the new EU directive, you have limits for the PBDEs in new products and also in recycled products. So for new chemicals and new mixtures, the limit is 50 ppm or 10 ppm for single PBDE homologues. And for the recycled, it's 500 ppm, milligram per kilogram. And there was just, we had the Global POP conference in China 3 weeks ago. And there was one presentation from the International Pollutant Network, and they showed that they made an assessment in Africa, and they found a range of toys which were below the EU regulation of 500 milligram per kilogram, but they had very high dioxins. So therefore, it seems that at the moment, the limit in Europe for the recycled plastic in respect, so that's for all products, including toys, is not protective. So we will see if Europe in future might further decrease here the limit. I can check if in the chat, I don't know if we can share also documents. Yes, so maybe I can share the presentation from iPen. Yeah, okay, good. Other question?
I think from Samir.
Good morning to you all. I have one comment and a following question to that about electronic waste. There is an unofficial cross-border traffic of electronic waste to Palestine, and there is also an unofficial industry for recovering the precious metals from such waste, and the remainings in many cases are burned in open space.
Yeah.
So this is the information. The subsequent question is, I heard somewhere that the XRF, the X-ray fluorescence technology, can be used to screen or measure the brominated fire retardants.
Yes.
You have any information on that?
Of course, yeah. Yes, I mean, first, this is just what I said yesterday when I made my presentation about dioxins, where I said cable and cable recycling and open burning. So just the site which you describe, which are receiving a kind of electronics to take the precious metal out, yes, and they will be polluted not only by dioxins, but also by PBDEs, by brominated flame retardants, and of course by the heavy metals. So this is, let's say, one side to describe. And I think there you really need to take regulatory actions, and you might need your environmental police to stop this practice. So, I mean, out of different reasons. I mean, one is, yes, the pollution of the environment, but you have exposure of the people. And finally, this kind of recycling and recovering is not actually optimized for recover these precious metals. So therefore, an export of these electronics to countries, I mean, in Belgium, in Germany is a big smelter. So they are gathering electronic waste from all over the world. And what you as an authority need to do is to use the valuable part of electronics and electronic waste and try to finance the overall management. Yeah, this will not be enough, but what you need to take care is that so-called cherry picking. This means that some informal or formal company just take out the valuable materials, recover it, and the rest finally is giving to society and is contaminating the environment. This should not be allowed. And now coming to your second question, yes, the XRF can screen not only brominated, they can screen brominated down to below 10 milligram per kilogram in the plastic. So you can nicely use it for separation. You can also screen toys, for example, and see if it was made from recycled electronic plastics by low level of bromine. So you can also find all the heavy metals screened with the XRF. Yeah, so the XRF can be used for the overall RoHS compliance. RoHS is the restriction of hazardous substances from Europe. And I already hear that, let's say, Palestine is looking to European regulations, and probably that you translate European regulations into Palestine regulations. So here with the XRF, you can make a screening for compliance of the overall RoHS limitations. There is one limitation. The XRF is only detecting bromine or non-bromine, yeah, and the concentration of bromine. It cannot tell if this is PBDEs or if this is another flame retardant. So what in Europe has been done, Europe has developed a so-called Senelec standard, which tell that you can screen your electronic waste plastic with the XRF, and if it's below 2000 milligram, then it is considered that the PBDE levels here in average are below the 500, because today the PBDEs are less than 20% then of the total brominated flame retardant in the e-waste plastic. Yeah, so therefore, yes, an XRF is a quite useful tool.
Okay, I think Dr. Nader Yagi.
Yes, my name is Nader Yagi from Hebron University. First, I would to thank Mr. Roland for the nice and valuable presentation. I want to make one comment about the e-waste. As a person living in Hebron, there is many sites for burning e-waste, and most of this electronic, it's coming from the other side. It's not from Palestinian sites. And there is many studies in Hebron area, especially in Edna. It's a village located in Hebron. The concentration of heavy metals and polychlorinated biphenyls and polybrominated biphenyls is very high above the standard value in atmosphere and in the soil. This is my comment, and thank you very much again for your nice presentation, Mr. Roland.
Maybe one recommendation for the government: try to formalize your informal e-waste sector. Yeah, and I mean, what you can do. I mean, the young people have time. You have many unemployed. You can look to the Vienna e-waste recycler, the governmental e-waste recycler in Vienna. So in Germany, you know, e-waste, when you do it properly and you separate, it takes time. So therefore, also in European countries, this is often not done. But in Vienna, they are using also unemployed people, yeah, so which are anyway subsidized by the government. And these get then really good jobs by this separation of the electronics. And let's say these guided separation results in a much better recycling and recovery, and it leads to a stop of open burning. So I think this would be a real great project for Palestine. I mean, to bring all the informal recyclers together, see how to formalize it. Yeah, I mean, use those people which are at the moment burning the waste. Yeah, and try to get an international project on this by a fund. I mean, yes, I know you do not get money from CHEF, but I assume that you get international support by different countries. I mean, either from the region or from Europe, and propose a project, yeah, on formalizing the informal e-waste recycler. And this is really a win-win situation for the people and for the environment and for the recovery of materials.
Yeah. Yes. Actually, recently, the authority started to establish some facilities to recycle and to extract the workable metals from the e-waste. But you know, some people is still using the burning site for to get this special metals.
Yes, I know. All countries have the same problem. I tell you, if it's Vietnam, even Turkey, yeah, it's not so easy to formalize the informal sector. Yeah, I completely agree. So you should also look, let's say, what kind of lessons learned in other countries to get it formalized.
Thank you, Mr. Roland.
Okay, now I am giving the floor to Bilal. After Bilal, I will give Bilal Amos. After that, there is more intervention is there. I am requesting you to put it in the chat box. So I am giving the floor to Bilal.
Roland, because I said in our website, is the LCA available through your presentation or not?
I mean, the presentations will be shared anyway. Yeah, so I will give Yasser all my presentations. And Yasser will,
Bilal, 1 minute. Dr. Roland, he already shared his presentation to us, and of course, we will share our presentation to the Yasser Abu Shenab, and you can avail these videos like Roland talk and all other talk through our SCRC channel, YouTube channel. We have the YouTube channel, and we are uploading the videos over there, and you can watch at any time those videos. Thank you.
Yeah, I mean, I will share the website of GIZ. They have a big project on e-waste recycling in Ghana. So that's a kind of lighthouse project from the German government in respect to e-waste recycling Africa. And there are a range of materials to download. So maybe that's a good start. I will do that in the chat afterwards.
Okay, thank you, Roland. Now I will give the floor to Bilal Amos.
Hi. 3 years ago, there was like an investigative reporting done by Al Jazeera about Edna in Hebron area, where these electronic waste were burned and recycled. And we did here at our center, testing laboratories at PZ, we did the technical part of that study. We only focus on heavy metals. There was samples from the soil, from the trees in the area, and from the groundwater. And actually, there was we found out that heavy metals like lead, like cadmium, are found in quantities like more than 2,000 ppm in the soil samples.
Yeah. Yeah.
So, but we did not do other. We only focused on heavy metals now. So there was really numbers exceeding sometimes 8,000 ppm in the topsoil.
Yes. Yeah, I mean the heavy metals also for China. You know, the biggest e-waste recycler in the world, starting 1990s, was China, and there were some cities where hundreds of thousands of people in that cities do the recycling. So there's one study about lead contamination of the whole city, and the whole groundwater. So yes, the heavy metals, and I showed you on one slide where I said yes, PBD is one pollutant, but please watch out the heavy metals or the PCBs. It is a multiple contamination, and also when we are talking about exposure of people, we need to consider these multiple pollutants, and especially that afterwards the soil is polluted for kind of forever. I mean, heavy metals are not degrading at all; they are fully persistent. Yeah.
Yes. Right.
Okay, thank you.